Here are the answers to our scientific measurement and calculations unit highlights. First up is scientific notation. So we see changing the numbers into scientific notation. When we have a number that is less than 1, then we have a negative exponent when the zeros are before the numbers, so moving the decimal to the right. And if we have a number greater than 1, moving the decimal to the left, we have a positive exponent. Question 2, how many sig figs are in our measurements? So again, the 0 in front, it is just cosmetic, so that is not significant. These two zeros definitely are. They were measured. These two zeros are not. They're naked. There's no decimal point there. These two zeros are. They're sandwiched in. And then this 0 is not, because it, again, cosmetic, and then everything to the right of the decimal is. So those are sig figs. Question 3, rounding the following measurements correctly. So if I need 3 sig figs, then the zeros in front don't count, the 1 and the 0 and the 2, but the 5 tells me to round up, so that's why I have the 3 there. For letter B, 3 sig figs again, 7, 0, 1. The 3 tells me to just drop the rest, so that's why it's 7.01. Letter C, 3 sig figs, zeros in front don't count, 3, 6, 2, and then the 9 tells me to round up, which is why I have the 3. And then the trickiest one here, rounding to 2 sig figs, I need the 8 and the 6, and the 7 tells me to round up. But I don't just write 87, I have to write these two placeholder zeros so that it rounds to 8,700 kilometers. You could have also, if you wanted to for that one, you could have written 8.7 times 10 to the second. Changing a number into scientific notation gets rid of the zero confusion. Your call. And then question 4, our SI units for these measurements: volume is a cubic meter, mass is kilogram, temperature is Kelvin, and length is meter. Question 5, the volume of a board measuring these dimensions. So the volume, I just have to multiply the 3 numbers together. Mathematically, the calculator tells me 483.12, but sig fig wise, because when I look at my measurements, 2 sig figs, 2 sig figs, 3 sig figs, so my answer can only have 2 sig figs. Adding here the total length of wire, so when I add that up mathematically I get 54.014, but again, sig fig wise, or correct rounding, hundredth, thousandth, tenth, so my answer can only go to the 10th, the least accurate of the measurements. Density of a metal for number 7. Well, to find the density, it's mass divided by volume, so the mass of the metal divided by the volume, and then using proper sig figs, 4 numbers in the volume measurement, I get 21.45 grams per milliliter, the density. And then I check my periodic table on the back of the one I gave you, and you can match that up to the metal platinum, pretty dense metal. Question 8 and 9, also about density, but solving for a different aspect. What is the mass of an object with that volume and density? This is my density equation, so solving for mass, I have to multiply both sides by volume. So the density times the volume will give me the mass. So my density times volume, using my proper sig figs, 3 sig figs in the density, so 3 sig figs in my answer, I get 704 grams. Number 9, again rearranging the density equation, solving for volume, it is mass divided by density. So when I take 50.2 grams divided by the density, I get 64 milliliters. Again, sig fig, I only have 2 sig figs in my density, so I can only have 2 sig figs in my answer. Question 10. A block of wood has this volume and this mass. What is the density, and will this wood block float? So you have to compare that to the density of water. Well, 140 divided by 120, my density is 1.2 grams per centimeter cubed, and this object, this piece of wood, would sink. If the density is greater than water, it's more dense, it would sink. Less dense, it would float. Question 11. Here we have a specific heat question. Sample of metal, start at a certain temperature, heat it up, it absorbed so much energy. What is that specific heat, and what metal is it? So there's my specific heat equation, and so I take the energy Q and I divide that by mass times the delta T. Remember that the delta T means change in temperature from 24 to 158. That's a difference of 134, so that's my delta T. So I want to make sure I do the correct order of operations, so either using parentheses on your calculator or multiply the bottom of the fraction first and then divide. But when I do that, and using my 3 sig figs, I get 0.444, and that's joules per gram degree Celsius. And when I look that up on the back of my periodic table, that is indeed the element nickel. Nickel on the back of your periodic table, nickelback. Okay, moving on. Number 12, here's a percent error question. So following the percent error formula that I've given you, the actual measurement, so that's what it's known to be, that's actual. So I have 4.75 in both of the actual spots. Measured was measured at 5.22. And remember that these are our absolute value signs, so I do not get a negative answer. 4.75 minus 5.22, and then I would divide that by 4.75, multiply by 100 to get a percent. Using my 3 sig figs, 9.89% error. And the last question is our temperature conversions. Remember, if I want to go from Celsius to Kelvin, I add 273. And when I go from Kelvin to Celsius, I subtract 273. I can have negative Celsius temperatures, not Kelvin. And just as a little reminder, we don't use the degree symbol with Kelvin. It's just a protocol, 600 Kelvin. We do with degrees Celsius. All right, good luck on your quest.